Hi guys, today we are going to see one of the important problem in the sliding window or two-pointer pattern. So please pay attention for this particular problem because the next two questions will be follow-up of this. Like we'll use the basic building block from this problem to every other problem also because it's very important. So take your pen and paper and get ready with me. So today we're going to see longest substring without repeating character. So what the question really asks you to do is, so they will give you input as a string with alphabet, I guess. So they mentioned character. So but let's take alphabet. Let's assume if you take character, it will be like 255 characters. So they will give a list of not a list. So they will give input string, and you need to find the longest substring. So what does substring means? So there will be a lot of confusion like what is substring, what is subsequent. So now let's clear out what a substring is. A substring is nothing but any part of a string. Please pay attention. Any part of a string that is contiguous in manner. So if you see CAD is also a string and it is a part of a string and it's in a contiguous manner. You can see it is next to next each other. And if you take BZA is also one of the substring because it's in a contiguous manner. And if you take like ABZ, so ABZ is not a substring. You see A is there, B is there, Z is there, but it's not a contiguous. So we're just skipping on character. So it's not a contiguous manner. Again, any part of a string which is in a contiguous is called a substring. So entire string is also a substring, and this particular is also a substring, and this particular is also substring, and the only thing is like you cannot skip the character, like you cannot skip this two, and you cannot make like this. That's the only thing. You need to find the substring such that there is no repeating character in it. Like for example, if you take in this given input, you can see C is CADZ. This is the particular answer. If you see this substring, there is no repeating character in it, right? And what is the length of it? So the length is 5. That's why the output is 5. And I hope you understand the given problem. So you need to find the substring such that there is no repeating character in it. Longest substring. Please pay attention. The longest substring you need to find. So now let's get into the brute force solution. So brute force is very simple. Like everybody initial thought is to generate all possible subset. All possible substring. That is very simple. You can start ij pointer, and you can have like initially CAD, and then you will have all the different possible string, and you will just move to next character A, and with starting A you will find all the different possible substring A, AD, ADB, and then dot 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 dot, and you will move to the next like DBZ dot dot dot, like that. You will find all possible substring and check whether it's valid or not. That's a very simple solution, right? So we can look into it. And before that, like one more question, guys. Like let's say you are just traversing to this particular area, and you are standing at this position. Okay, so how do you find A is already exist or not? I mean, like we visited A or not, how do you find very efficiently? Just think for a quick second. If your answer is set, then that's well and good. It's like it's a correct answer. So if you use set, we can know that whether we visited or not. You can use array also, it's your wish. So with constant time, you can check whether we visited A or not. So we'll use set for visiting purpose to check whether it's already visited or not. So now let's get into the code. There'll be max length, which is our result, and then for loop starting from I till the 0, and then we have current max. What is the current maximum length we can get? And then we have character set. So character set is going to be like size of 26. So we assume like that because character has 255. If not, like 26 or 255, that's going to be space complexity. For simplicity, let's start from I, and then this base case, like as I mentioned, for visiting purpose we'll use set. So we are just checking if the current character is already visited. If it's already visited, which means it is no longer the valid subsequence, so we just break it. For example, on the initial iteration, we'll just visit all this thing, and when we try to visit this makes our substring as invalid, right? For invalid for the given question. So given question has without repeating character. If we include this entire thing will become invalid. So that's why we are just breaking out of the loop. And if the condition is passed, like what we will do is we'll calculate the maximum window. So to calculate the window size, please remember this is the formula. Like everywhere in two pointers or sliding window, use this, which is j minus 1 plus I. So this will give you the current valid window. So we'll just update the max length, and like whenever we're visiting the character, we'll add it to this set. That's what we're doing it. Char dot set add current character. It should be j, not I. Sorry, it should be j. It is j. And that's it. At last, we can return max length. And let me explain you how this works. So let's say this is the index 0, right? This is the index 4. And if you apply the given formula, what is the formula is j minus I plus 1, which will give you length of 5. And if you count how much character here, 1, 2, 3, 4, 5. 5 character, and this is the window size. That's why we use j minus I plus 1. Okay guys, now if we talk about time complexity, this is going to be big O of n square because we use 2 for loop, right? And then if we talk about the space, as I mentioned already, this is going to be big O of 26, which is almost constant space. It's not going to be n space, it's going to be constant space. And now let's move to the better solution. Like, do you find like any better time complexity, like which is better than O of n square will be O of n? Like, how can we achieve this? Just think, guys. It's very simple. You can achieve O of n square, O of n time complexity with two pointer and sliding window pattern. And before moving to the solution, I want to tell about this sliding window algorithm. So like this two pointer or sliding window algorithm, or like not a constructive based algorithm. These are like a specific algorithm. Like you will just understand what is the basic of it, and depending upon the question, you will just apply the logic. But if you take constructive algorithm, let's say a star algorithm or binary search algorithm, these are like a constructive one. It has predefined step. For example, you will have a low pointer and high pointer, and you will find the mid. And if mid is greater than some specific value, you will just move the value. If not, you will just move low value. Like that, you have some constructive kind of things. So you will apply a similar thing for every other solution. But if you take this type of algorithms, like these are like a specific one, specific oriented to the particular problem. So what I mean is, if you take a previous problem, we have pointer at like this position, one pointer is here, one pointer is there. And if you see like previous problem, I mean one of the problems, say we have two different pointer here, and we apply, depending upon the question, we apply the pointers or a window. But if we take this problem, we have at the same position, and you learn just the basic of it, and you will apply to the different problem. That's what this two pointer sliding window is. Like you need to understand the basic very well. Now let's move on to the solution. As initially we'll have two pointers, like one is R, one is L at the same position. So I think for better understanding, let me write the index number 0, 1, 2. Okay, so I written the index number. It is pretty clumsy, sorry for it. So as an initial step, this is going to be dry run table, and this is the set for checking whether it's already visited or not. So as initial one, let's fill out this table first. So for iteration 0, before that, like we just move our pointer only. Keep in mind, we just move our pointer only. So current substring. So current substring is C. Am I right? Right now the current substring is C, and what is the max length? So far max length is 1. Now we'll move to the next character, and when we move to the next character, we need to add it to the set. So we have seen C, and right now what is the current substring? CA, and max length is 2. So we just move the pointer to the next position, which is CAB. Now don't forget to add A to the HashSet. And what is the maximum length, which is 3. And you will move the pointer to the next position, and after moving it you will add the character to the HashSet B. And next iteration CABD. So what is the maximum length right now? 4. Make sure these are valid thing. Okay, CABD is a valid thing. And right now we'll just move the pointer to the next position, and after moving it we'll add D to the HashSet. And next iteration will be CABDZ. Maximum length is 5, and that's it. Like, we'll move that pointer to the next position, and after moving it we'll add Z. Now this is a place where we need to pay attention very carefully. Now, like, we cannot take this as a valid particular string because A is already repeated. Question is, we need to find longest substring without repeating character. Now what we should do? This is where the case 1 occurs. Like, whenever you just have the character in HashSet, like if you check, like if the current character is in a set, it will just tell true because A is already there. Now what we have to do is, it's pretty simple. Just move the pointer, just move left pointer right now, move the left pointer to the 1 position. Now after moving it, you have to remove this particular character from the set. So you just remove C from this set. Now check whether this particular string is valid or not. Do you think it's valid? Nope, because A is repeated 2 times. Again, just move left pointer 1 more step, and now strike out A. A is striked out. Now tell me whether this particular string is valid or not. Yeah, it is a valid string, substring. So right now you can enter this current substring there, like B, D, Z, A. And don't forget to add A to the, we need to move this pointer, right? So don't forget to add A to the set. We added A, now max length is 4. At the next step, tell me whether this window is valid or not. Nope, it's not a valid window because B repeated 2 times. So we need to move left pointer 1 step ahead, and we need to remove B from the HashSet, right? Remove it. Now tell me whether the given string is valid or not. Yeah, it's a valid sequence. So just put it to the try run table. D Z A B. Now the max string is 4. Now let's move the next pointer. Now tell me the given string is valid or not. Yeah, obviously the given string is valid. We can just directly do this, like iteration 7 D Z A B C, which is max length of 5. And just move the pointer to the, and I forgot, right? I forgot to add B, and when you're moving this pointer, we need to add C also in the given set. Yeah. Now tell me whether this particular string is valid or not. No, because D is already repeated 2 times. So what we have to do is just move left pointer 1 position and remove D from the given string. Now remove the D from set. Now tell me whether this particular string is valid or not. Yep, it's a valid. 8th prior G, A, B, C, D, which is 5. Now tell me guys, what is the maximum possible length you are getting? The maximum possible length is 5, which is this, which is this, which is this. Again, the question asks you to return only the length of it, so you don't need to worry about this string. These are the different possible substring which gives you length 5. You can directly return 5 length alone. So I hope you guys understand this approach. Now let's write the pseudocode for this particular solution, and only there will be slight optimization from this. So first let's talk about the pseudocode, and then we'll see the optimal solution. So initially we'll have the set, right? So visited set, visited is going to be a set, or depending upon your language you can create a boolean vector also. For me, I'm comfortable with set, that's why I'm using it. For boolean vector, what we have to do is, like, initially set to the false and size of 26. You can have an array like this. Typically in CPP they used to do like this. They used to have visited boolean array, but I am comfortable with set. Okay, now what you have to do is, we have max length. Max length is always set to 0, and we'll start a loop for r is going to be 0 till the n, and don't forget l is also at a 0th position. Now like what we have to do is, now we need to check if, or we can have while loop, because if we take this position, like until unless we make a valid window, we just move the pointer. Am I right? For that, what we have to do is we need to write a for loop. Sorry, not a for, while loop. So while s of r, this is a current string, while s of r in visited, like which is violating the given question, right? It should not be there. So what we have to do is we have to just remove the left character. We are moving left pointer, right? If you remember, we are just moving left pointer one step ahead. So when we are moving it, we need to remove this particular character. So visited dot remove s of left. That's right. Now we need to move l to the next position, and that's it, guys. So once this loop finish, we'll have valid window. Now we'll have the calculate the window size. Size is going to be r minus l plus 1. This is the current window size, and we'll update if max length is going to be max of max length comma current window size. And as always, like whenever we visited, we'll add to the visited dot add s of r. That's pretty simple, right? And you can directly return max length. This is a very pretty simple basic solution, right? If you talk about the time complexity, this is a bit tricky part. Time is going to be big O of n for this particular loop. But if you take this inner one, this at max, the worst case, it will also take big O of n time. This plus, not a multiply. The reason, because at the worst situation, like how much time you visit. Let's say, let's take this same let's say this example C. Now what is the maximum substring? This is the maximum window, and no, wait, instead of this we'll have Z. This is a better one, yeah. So now this is the maximum longest substring, right? Now when you encountering this particular substring, this is invalid. So what you will do, you will move the pointer, like L will be here at this position and R will be here. Now to make a valid window, you will just move L pointer only one side, right? Now you will check this particular window is valid or not. Nope, it's not valid. So you will again move the pointer to this position. It's valid or not? Nope, it's not valid. So again you will move the pointer and you will check it's not valid. Again, it's not valid. And when you're encoding this position, it's a valid. But if you see right now, we just skip these many positions, so which is kind of n. So that's why it's going to be big O of n, and the space, again the space is going to be big O of 26, and this is almost big O of 2n. This is big O of 1 constant. So we can make this as a better solution. How we can do, just think guys, how we can make this a better. Already it's a better one. Big O of 2n is compared to n square. This is already better solution, but again we can make this to the better, a way optimal solution. That's what we are going to see in the next approach, which is optimal one. Typically same thing. Do you remember, like we are using set to keep track of the visited thing, but in the given problem, this particular problem, we are going to use hash map. Remember hash map, hash is not hash set. We are going to use the hash map for it. Let me draw out this hash table. Hash map is going to be like this. So what is going to be our key? Key is going to be the character, and the value is going to be the index. Okay guys, it's going to be index. This is going to be key, and this is going to be the value. And the similar logic for from the previous problem, we'll have the two different pointers, and whenever we are just moving the pointer, you just add the character with the index of it. Okay, you have to add character and index of it. Now the current string is CA. Now it's already valid, so just move one position. Now add a comma 1 to the hash map. Now again move this pointer. Again, I will move this again. So for simplicity, I'll directly come to the invalid case. So we have to add b comma 2, d comma 3, and c comma 4. Now if you see this particular case, it's invalid. So let's talk about in detail. So this is the first case, like in this position, like let's say we're just getting an invalid, like repeated character. Now what you have to do? So previously what you did is like you just move the pointer and check whether the current window is valid or not. You just move the window, move the L, and check the current window is valid or not. That's what you're doing, right? This kind of repeated, isn't it? Like the goal is you have to find this repeating character and move the pointer to the next position. That's what your goal is, right? Then your substring become valid. If you take this thing, it's invalid. So when this will become valid is when you find this particular repeated character and move the next position to it. You have to move the L to the next position of this particular repeating character. That's what your answer also, right? So the repeating character is this. So you have to move L to the next position of it. Am I right? You have to move next position of it. So if you move it, the L is going to be here and R is going to be here. So if you see this Windows, particular window is valid. Again, same thing happens here. So this particular, when you encoding this, you will find the repeating character index and move the L pointer to the next position. That's what you're doing manually, right? Every time you're just checking for loop and you're doing it manually. So we can reduce this process very simply with the index position. So we have index already. So what we can do is initially like that, assume if current character in hash in visited. For this previous problem, we have while loop to fix this thing. Right now, we don't need a while loop. We can come to this if case, and what we can do is assign the left. The left is going to be hash of the current character plus 1. So current character is going to be string. This will give you the index position of it, and you need to add +1 because you need to move to the next position. Am I right? That's pretty simple. And then you need to update the hash also. So whenever you moving the pointer, you need to update this hash also. Hash is going to be hash of current is going to be left. Please pay attention. You need to update the hash also. So let's see here like what's happening. Now L is going to be initially L is going to be 0. R is going to be at the position. R is going to be at position 5. So, right now this invalid case occurs. As mentioned, left is going to be hash of A. So current character is A, right? A plus 1. What is A? If you take this position, this hash string, A index is 1. So left will be like 1 plus 1, 2. So we have to move left to the index position of 2, which is index 2, which is B, right? Now you need to update this particular A, right? So now particular A is going to be like hash of A is going to be or sorry guys, I said here left, but it should be right. Make sure to update it. Right now our A lies in this position. So this will be A comma 5. Right now, very simply, we just replace the character, right? Previously, we had this while loop. We used to just check like this. But right now, we just optimized it simply by utilizing the hash map concept. We just did it. Now let's move on to the dry run. Now we'll move our pointer to the next position. Do you think this substring is valid? No, it's not a valid. Right now, where is our L? L is at second position. R is at sixth position. Now we need to do this particular case because B is already visited. You can see B is already visited. Now left is going to be hash of B plus 1. What is the hash of B? Index position of B is 2, and if we add 1 to it, it will be at 3. What is index 3? Index 3 is D. If you move the L to 3, now this particular window will become valid. Am I right or wrong? It's a valid window. Now we have to update the hash also, right? hash of B is going to be R. So what is the R? R is going to be index 6. So just update B to the 6. Yeah, that's it. I think we can stop the dry run from this. I hope you understand this particular optimal solution. And if we talk about the time complexity, it is big O of n time, and space is going to be again big O of 26, which is almost a constant one. So this is the most optimal one. And now let's code this up. This is a medium problem, guys, and this is lead code 3 question, which is the famous question. Now let's code this up. So initially we'll have max length, right? Max length is going to be, as always, it's going to be 0, and we'll have left pointer 0, and the visited, not visited. Now we are going to use hash map, right? Hash map is going to be this thing, and for Python, I'm going to use default left. Start the for loop for r in range from 0 till the length of s. I think I'm putting extra brackets. Now we need to check if the current character s of r in hash map. If it's there, what we have to do is we need to update the left pointer, right? Left is going to be hash map of s of r plus 1. So skip the L to next valid place. So now if you remember, we need to update the hash also. Hash map of s of r is going to be the r position. Now if not, we will calculate the window. Like window is going to be, if you remember the formula, window is going to be r minus l plus 1, and we'll update r minus l, right? R minus l plus 1. Now we'll update the max length. Max length is going to be max of max length comma the current window size. That's it, guys. You can directly return max length. If you run this solution, let's see. Oh, it's written wrong. I forgot to add the value, like hash map of s of r is going to be r. Yeah, I'm sorry. Yeah, now we just pass all the test cases. Now let's submit the solution and see. We are just getting some invalid test cases. Now let's debug this lively, what we did. Answer should be 2, but we have 3. Okay. So what is the issue right now? So maximum length is okay, default length. Yeah, guys, I just found the issue. What is the issue is, like whenever we're just skipping the L, this should be the valid place. So you cannot keep the L in the lower position. For example, sometime this S of R plus 1 can be less than this L. So let's say L is at 10th position, and S of R plus 1 gives you 3 position. So you don't want to move L to the 3rd position, right? So for this, what you have to do is the max of this next valid position, comma the current position itself. So let's see, like with example, like for example, L is at 10th position and R is at 15th one, and you will see hash of 15, right? You will check this one. Hash of 15. I mean, let's assume character C, but C occurs at the 3rd index. So what you will do is L is going to be hash of we said R is character C. 3 occurs at 3rd index. So you will do 3 plus 1. Now your new L is going to be 4th position. This is technically invalid, right? Again, you are just shifting your pointer backwards. L is already at the 10th position. We're just moving it backward. Again, you're making window invalid, right? So you should not do it. So what you have to do is you need to always maintain a correct window. For that, you can have the L. I mean, technically it should be 10 or more than 10. So you cannot have less than 10. So that's why this error occurs. So for that, you can simply add max of the next valid position or the current position itself. So if you apply here, it will be like the max. So max of 4, which is the next valid position, the current position 10. So which will be assigned to L is 10. So we always need to have the maximum position. That's why we just got this error. So now let's submit this. Yeah, we just passed all the test cases, and which is optimal one. let's see the time complexity of this particular problem, which is big O of n. So I hope you guys understand the problem very well. We'll meet again in one more problem. Until then, keep watching. Bye.